Welcome back, guys. Today's video is going to be covering the concept of isotopes. Now, isotopes are simply different forms of the same atom that only differ in their number of neutrons. So if we take chlorine, for example, right? Chlorine is number 17 on the periodic table. That means its atomic number is 17 and it has 17 protons. Now, if we look at these two different versions of chlorine, we notice that the atomic number, which is written in the bottom left, doesn't change for either chlorine, right? So we have chlorine 35 and chlorine 37, right? That's the mass number for each of these chlorines, right? So we know that the atomic number stays the same, but we see that for chlorine 35 and chlorine 37, we have a different mass number. Now, what does that show us? Well, remember, that mass number is the number of protons plus the number of neutrons, right? So if we look at chlorine 35 and chlorine 37, they both have the same number of protons, and that goes for every single isotope, for every single atom, right? So chlorine is not the only atom that has isotopes. A lot of atoms on the periodic table have different isotopes. It's important to note that the number of protons never change. It's the number of neutrons that are going to change. So if we look at this form of chlorine, chlorine 35, it's going to have 17 protons, right? And its mass number is 35. So that means it's going to have 17 protons and 18 neutrons, right? That's going to add up to 35. Now, if we look over here, it has 17 protons, right? Protons plus neutrons is going to equal 37. That's the mass number. And make sure to watch my video on atomic number and mass number to get a review of this. So if we have protons plus neutrons equaling 37, and we still have our 17 protons, that must mean that we have 20 neutrons in chlorine 37. So just as a review, we have chlorine, right? There's these two isotopes or versions of chlorine that differ only in their number of neutrons, and we're going to see that when we see the mass numbers change, right? Now, why is this a big deal? So when you have different isotopes, they have different number of neutrons, right? And when you have a different number of neutrons, you're going to have a different mass, right? Neutrons have a mass associated with them, and if you have 20 neutrons versus 18 neutrons, you're going to have a different mass. Now, we can see over here some data. We have the mass of chlorine 35 as 34.96, and we have the mass of chlorine 37 as 36.95. We can see that because chlorine 37 has 2 more neutrons than this chlorine 35, it's going to have a larger mass. Now, when is this going to come into play when we have to solve a problem? So we know that there is a different number of neutrons, but how are we going to have to solve a problem with isotopes? So it says chlorine has 2 naturally occurring isotopes, chlorine 35 and chlorine 37. Remember, when you see it written like this, these are the mass numbers. Calculate the average atomic mass of chlorine. So what is the average atomic mass? So this is a really important concept that you definitely need to know. So if you look at the periodic table, for all of the atoms, you're going to see a number at the very bottom, right? This number right here is the average atomic mass of that atom. Now you'll also see this written as the molar mass or average atomic mass, right? Those are synonymous terms. Now, for every atom, you're going to see that molar mass or average atomic mass written, right? So for something like carbon, you're going to see 12.0107, right? That would be carbon's molar mass or average atomic mass. Now, if you saw something like CO2, right? If you wanted to find the average atomic mass or molar mass of the molecule CO2, all you'd have to do is add up the mass of carbon and the mass of these 2 oxygens, and you have the total molar mass or average atomic mass of that molecule, right? But this video is focusing more on isotopes. So if we're going to calculate the average atomic mass of chlorine, this is what we're going to have to do. So average atomic mass is essentially an average of the weight of all of the isotopes of that atom. So if we're looking at chlorine, 35.453 is more of an average of the mass of chlorine 35 and chlorine 37 added together, right? So when we calculate the average atomic mass of chlorine, we should get 35.453 as our answer. Now, how are we going to do that with the math? So we're going to have to come over here, and we're going to have to look at our mass of chlorine-35 and our mass of chlorine-37, and we're going to have to use those values to get this number. So let's do that. So before we can go and calculate that, let's look at what these are telling us, right? This is the percent abundance, okay? Now, what does percent abundance mean? So essentially, if you were to find a sample of chlorine in nature and you were going to, find that sample and pick it up, right, and look at it, what it's saying is that you'd expect 75.77% of that sample to be chlorine-35 and 24.23% of that sample to be chlorine-37. Percent abundance is essentially telling you how much of each isotope you'd expect to find. So essentially, if you thought of it as a 50-50, chlorine-35, chlorine-37, you'd be thinking about it incorrectly, right? We're actually going to see more of this other isotope than this chlorine-37. So percent abundance is going to help us with this average to get this overall 35.453 number. So if we want to get that number out, right, we're going to have to follow a certain formula. So if we want to find the average atomic mass, right, the average atomic mass, right, or the molar mass, that's going to be equal to the mass of isotope 1 times its percent abundance plus the mass of isotope 2 times its percent abundance. Now, chlorine only has 2 isotopes. If we had an atom with more than 2 isotopes, we can continue on with this formula by continuing to add mass of isotope 3 times its percent abundance, and so on and so forth. So what we're going to do here, if we want to calculate the average atomic mass, so the average atomic mass, which remember, we should get 35.453 when we, finish substituting in the numbers. So our first isotope is going to be chlorine-35, and it has a mass of 34.96. So it's 34.96. Its percent abundance, right, that percentage that we expect to see in that sample in nature, if we were to find one, right, is 75.77. So that's 0.7577, right? You want to convert that to a decimal. Plus the mass of our isotope 2, which is 36.95, times its percent abundance of 24.23%. Convert that to a decimal. So as we can see, to find that average atomic mass, we're taking that average of the mass of each individual isotope, right, with this formula, and we are going to get 35.453 if we were to multiply this out, and add them together. So just as a summary, isotopes, we can see different forms of the same atom. They differ in that number of neutrons, therefore they differ in that mass number, and when you have a different number of neutrons, you're going to have a different weight with each isotope, and if you want to find the average atomic mass, which is that number on the table, you're going to use this formula to find that average, right, with the different isotopes, multiplied by their percent abundances, and out comes the average atomic mass or molar mass. So hopefully you enjoyed this video. Definitely check out the channel for more videos.